Welcome to ThinkDart. Imagine standing on a platform that stretches endlessly into the sky, a structure so tall that its top isn't just above the clouds, it's above the planet itself. A single thread of engineering genius that connects Earth to space. It sounds like science fiction, but right now, some of the world's greatest minds and most powerful companies are quietly racing to make it real. This is the story of the space elevator, humanity's most ambitious dream to reach the stars without rockets. And it might just change everything we know about space travel. Let's begin with a simple question. What if we could reach orbit not with explosions and fire, but with elegance and precision? No fuel, no rockets. Just a ride straight to the heavens. That's the idea behind the space elevator, a massive tether that stretches from Earth's surface all the way to outer space. Think of it like a cable thousands of kilometers long, anchored on Earth and held taut by a counterweight orbiting high above. If such a structure could exist, spacecraft, satellites, and even tourists could climb into orbit as easily as taking an elevator. No smoke, no noise, no pollution. But this isn't just a crazy fantasy. The concept was first proposed more than a century ago, 1895, by Russian scientist Konstantin Tsiolkovsky. Inspired by the newly built Eiffel Tower, he imagined a celestial tower that could reach into space. His idea was impossible at the time. No material could withstand the weight. But the seed was planted. Fast forward to today, and that seed has grown into an international race. NASA has studied it. Japan's Obayashi Corporation claims they could build one within this century. Elon Musk and SpaceX, while focused on rockets, have commented that a true space elevator could revolutionize orbital transport forever. Even private startups and researchers in China and Europe are quietly testing materials that could make this dream possible. So, what's stopping us? One word: materials. To build a space elevator, we need a tether strong enough to stretch from the surface of Earth, about 35,086 kilometers, up to geostationary orbit without snapping under its own weight. For decades, nothing came close. Steel, too heavy. Kevlar, too weak. Then came a discovery that changed everything: carbon nanotubes. Carbon nanotubes are microscopic tubes made entirely of carbon atoms, arranged in a perfect lattice. They're incredibly light, yet hundreds of times stronger than steel. In theory, a ribbon made of carbon nanotubes could be strong enough to support a space elevator cable. That's why researchers around the world have spent the last 2 decades racing to make them long, pure, and defect-free. In 2014, a team from Japan's Obayashi Corporation, a construction giant, made headlines by announcing plans for a space elevator by 2050. Their engineers proposed a 96,000-kilometer-long carbon nanotube cable with robotic climbers carrying cargo and eventually humans into orbit. The estimated cost? Around $100 billion. Enormous, but cheaper than launching thousands of rockets every year. NASA, too, has been funding studies on the concept. In fact, NASA even launched the Space Elevator Challenge, offering prizes for anyone who could build working climbers and tethers strong enough to make it real. The competition led to breakthroughs in laser-powered propulsion and lightweight cable design. Though no one's cracked it yet, each year brings us closer. And then there's Elon Musk. He once joked that a space elevator is only possible on smaller planets like Mars because Earth's gravity makes it too hard right now. But even Musk admits that if we can create the right material, something stronger than steel, lighter than air, the idea could transform how SpaceX, NASA, and every agency explores the cosmos. Blue Origin, founded by Jeff Bezos, has also shown interest in alternative launch systems, from reusable rockets to space habitats. Their long-term vision? Millions of people living and working in space. And a structure like a space elevator could be the key to making that dream sustainable. Let's pause for a moment and imagine it's finally built. The base sits somewhere near the equator, perhaps in the Pacific Ocean, where the rotation of the Earth provides balance. A ribbon of shining carbon nanotubes stretches upward beyond sight. Robotic climbers, powered by lasers or solar energy, ascend the ribbon at hundreds of kilometers per hour. Cargo modules glide silently into orbit. Up there, at the geostationary station, 36,000 kilometers high, a spaceport awaits. From there, smaller vehicles could travel to the Moon, Mars, or beyond. A one-way ticket to the stars without ever lighting a single rocket. Sounds like a dream, doesn't it? But dreams come with dangers. A structure this massive would face unimaginable challenges, from weather to orbital debris. Imagine a satellite drifting into the cable at 30,000 kilometers per hour, or a micrometeorite slicing through it like a bullet. One break and the entire ribbon could snap, whipping down to Earth with catastrophic energy. To prevent that, scientists are exploring segmented designs, self-healing materials, and dynamic tension systems that can adjust to stress. There's also the problem of energy. Climbing 36,000 kilometers isn't easy, even without gravity losses from rockets. Engineers are studying laser beam propulsion, where ground-based lasers beam power directly to solar receivers on the climbers. It's elegant, clean, and potentially endless. But perhaps the biggest obstacle is cooperation. Building a space elevator would require global coordination unlike anything before. One country can't do it alone. It would cross borders, airspace, and orbital zones. It would need international treaties, new laws, and decades of trust between nations. Yet, in a world divided by politics and competition, could humanity truly unite for something this big? That's why many experts believe the first space elevator might not be on Earth at all. Mars, with its lower gravity and thinner atmosphere, could be the perfect testing ground. A Martian space elevator would be shorter, lighter, and easier to build. In fact, NASA researchers have already modeled what it would look like. A tether anchored to the Martian surface, extending to a stationary satellite in orbit. It's possible that humanity's first elevator to the stars won't be built on Earth, but on another world. Still, progress continues. Every year, scientists create longer carbon nanotubes. New materials like graphene and diamond nanothreads promise even greater strength. And with each step, the impossible becomes slightly less impossible. In 2022, researchers from Cambridge University demonstrated kilometer-scale carbon nanotube fibers, still far from 36,000 kilometers, but an incredible leap forward. Meanwhile, private space companies keep pushing boundaries. SpaceX is launching rockets weekly. Blue Origin is testing reusable engines. And while none of them are directly building elevators yet, every improvement in material science, energy transfer, and robotics brings that future closer. Now imagine 50 years from now, a child boards an elevator at a floating base near the equator. The doors close. The floor hums softly. Outside the window, clouds drift below, then disappear. The earth curves beneath, blue and alive. Hours pass. The child looks down and sees an entire planet shrinking below their feet. That is the promise of the space elevator. A world where reaching orbit isn't the privilege of the rich or the dream of the brave, but a journey anyone can take. A future where humanity is no longer bound to the ground, but truly becomes a spacefaring civilization. NASA calls it the ultimate transportation system. Elon Musk calls it technically hard, but not impossible. The Japanese government calls it a step towards sustainable space development, and futurists believe it could mark the true beginning of the next human era. But here's the question. If humanity does build a road to the stars, who will control it? Will it be NASA, serving all humankind? Or SpaceX, turning it into the next great commercial highway? Or perhaps a nation that sees it as the ultimate symbol of power, the ability to move between Earth and space at will? Whoever reaches first will hold the key to the future. And as the silent race continues, engineers, dreamers, and visionaries keep climbing, not just into the sky, but into history itself. Because in the end, the question isn't whether we can build a space elevator, it's whether we're ready to rise beyond our limits. What do you think? Will humanity one day ride an elevator into the stars? Or will this dream stay forever out of reach? Tell us what you believe down in the comments below. Thanks for watching, and keep looking up.